Okay, so for company one, let's call that X days. And for company two, we'll call that Y days. Company one makes 20 Lambos and they make 10 Lambos. And we need 5,000 Lambos. It says at least 5,000. And then Ferraris, and we need at least 12,000 Ferraris. And then 20 McLarens a day. And we need at most 30,000 McLarens. Now the objective is to, right here, find how many days each company should work so that our operational costs is minimized. There's 60,000 for a day for company one to operate, and then 40,000 a day for company two to operate. So taking in all these conditions, here are the constraints and the objective function. So we're gonna have company one working for X days, and company two is gonna be working for Y days. Now, what is the objective? We want to minimize costs. And it says that company one costs $60,000 a day. And in company two, $40,000 a day they need to just survive. And that's times Y days. Now, this is supposed to be minimized, right? If we're the owners of this company, these companies, we want to spend as little money as possible. So we're going to minimize this number. So we know that the first company, if you look at the word problem, one of the companies makes 20 Lambos a day for X days. And the other one makes 10 Lamborghinis. So right now we're just talking about Lamborghinis. 20 from one company, 10 for the other. And it says that we want to make, the keyword is at least. So I want this number to possibly be bigger, but at the smallest, it's going to be at least 5,000 Lamborghinis. It should look something like this for Ferraris. At least it says 12,000, and it says that it have to make at most 30,000. So our limitation, we are bounded by a limit of 30,000 McLarens. So these are the constraints. So now what we can do is we can graph these on Desmos, and let's see what shape we get. So on Desmos, if we zoom out and if we possibly pinch the y-axis, let's pinch the y-axis so it looks more convenient. And the region with all the colors is the region of interest. This space here is what we want to look at. We want to test this point, and we want to test this one. And it looks like there's a point here and a point there and a point even right here. So these 5 points, let's test these 5 points and see which one leads to the least amount of money spent by our companies. So looking at all these 5 test points with X, Y, X, Y, X, Y, X, Y, X, Y, we test this X and Y here, and this is $60 million. Now what these numbers mean is, this is how much money it would cost to have the 2 companies open so that all these cars can be made. The best combination would be this one here, where company one, we're gonna have them open for business for 150 days. Company two, we're gonna have them open for business for 200 days. And with this combination, we're gonna get all the cars constructed and we'll be spending the least amount of money possible. So final answer right there.